Okay, so the time is up. That is the set point of the interruptions that we will always get. So the reduced shape of the previous one was not there, but there is a reverse thing that we will try and show you over here, right? That is basically where we will end today's lesson. And then for those people who had extra questions after my next class, if you still have data or time, we can go through the questions that we have. That is this one's over here. Most of you did answer the first two, but you got stuck as we continue down, especially with the rotation part I've just explained, and enlargement part is now what we are basically busy with. And then we are basically done. With this invariant points, it used to be for a higher level, but we only also mention it. It has to do with a line of symmetry, and it also has to do with your reflection line. Okay, so line of reflection, line of symmetry, and then the last one was just for you to come up with your own answers if you like to, right? So I wanted to go through those, but time is not always on our side. It takes a long time to explain, and if I go fast, it's not a problem again. So with this one, we have the shape R, and we have to enlarge it using a scale factor of 3, and the center of origin is -2 and 1. So this one, since the center of origin is inside the shape, which I told you the last time that it can also be inside the shape. So we will just follow the rules. We will join the points to the center and then extend the line outwards as far as you possibly can. It's also fine. We'll do that for all the points. All right. And once you have all the points, then we will multiply each of the coordinates. This one is 1, all right? 1 and 2, we multiply it by 3. It gives us 1 times 3 is 3, and 2 times 3 is 6. And then that is our new coordinate that we have. We do it for the other side again. The coordinate for this one is x is okay, it doesn't clearly say what the x is here, but x is supposed to be 7 and minus 5. Sorry, not 7 and minus 5. I went a little bit over. X is supposed to be here on this point. X is supposed to be minus 3 and minus 1. And then you are supposed to multiply that. But this is not to scale, because here it also says that our new coordinates is a little bit bigger than what it has. But with this one, everything was okay. All right. So that now means when we are enlarging, we just go according from this side. We don't count from 0. That is the important part that I always omit. When we have a center of enlargement, like I told you in the previous one, where we get wrong is we start assuming that when we are counting the positions, we are starting to count from 0. And this is where the problem comes. When we count from 0, then it becomes a problem to answer all the other things, because you are assuming that the coordinate here is this, but it says you have to start your coordinate from this point. So if you are starting at this point, let me just quickly show you using a pen what the coordinates are. I'm just going to go back. Let's just go back quickly, because we didn't do that correctly. So if this is the center of origin, right, and we are looking at this coordinate here, right? So this coordinate over here, and this is now the new center. So this is having an x value of 1 and a y value of 2, all right? So x is 1, y is 2, not 3, 2, okay? I'm writing it down because this is the center. when you multiply this by 3, okay, when we multiply it by 3, then your x will be 3. So it will be 1, 2, 3. That is 3. Your y will be 3 times 2 is 6. So if this is your 0, your y will now go 1, 2, 3, 4, 5, 6. That is the coordinate that we have. So when your origin is defined, then you have to make use of the origin. And we are not counting the coordinates in terms of 0. So if you start at 0, like you're saying, okay, from 0, this will be a minus 1, 2, 3, minus 3. And from 0, it will be a 3. So this is from 0. And when you use from 0, it becomes a problem. Okay, when you are multiplying now by 3, you'll get minus 9. And if you multiply by 3, you will get a 9. So then you will see it goes beyond the paper and it becomes now a problem somewhere there on top, because you have now used center of origin 0. So we do not want to use center of origin 0 always. We use the center that they give us, and sometimes we have to define where our center is. So if we define where our center is, I will show you using a line diagram how we can define where our center is. That is the best way to do it. All right. So remember that assumption of you must always use 0 is where the problem always starts. Don't use 0, use the one that they give you. If this is the one they give you, then this becomes your 0. All right. Everything else you count is from that one. Ivy, please stop writing on the thing. Okay, so that is what we mean. So this is now my new 0, 0. And then I start counting this coordinate from this point here. So it will be 1 for x and 1, 2 for y. Remember that one. 1 for x, 2 for y. This coordinate, if that is my 0, it will be minus 1. Sorry, it's minus 1. It will be minus 1 for x, all right, and minus 1, 2 for y. So this is minus 1 for x, and it is minus 2 for y. And then this coordinate over here, not at this 0, from the new 0 that we have, it will be 1, 2, 3 for x and minus 1, minus 2 for y. So this will be 3 for x and minus 2 for y. So I hope I've explained now again the coordinates that we will be having here. Students from grade 9, just hold on a bit, right? So this is how we do it. And then you will use this now, this coordinate that we have defined, and multiply it by 3. And then once you get your answer, you will again use this 0 and not that 0. Okay. So like I said, minus 1 times 3 is minus 3. That's why we went 1, 2, 3. That's the 3 minus 3 over there. And you can see this minus 3 is not just at the same place of minus 3 with the 0. It's at a different position. That is the important factor that you need to know. And 2 times 3 is 6, and the 6 will start here to go up 1, 2, 3, 4, 5, 6. So you can see my 6 is also not in the position of the 6 on the origin y and x line. It's on a different line, and that's why the 6 is at a different place as well. And where they two join, that is our point. And we do the same here. It will be minus 3 and minus 6, but we start counting from this point, minus 3, and then we go down minus 6. And that is the point over there. And we do the same for this. This will be 3 times 3 is 9. You see there's no 9 on this, but we start counting from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There you can see this is now my new 9 because I'm counting from the origin. And minus 2 times 3 is just 6. We already defined where the 6 is, and that is on the same line over here. And where the two join, that is our point. All right. So I'm going to clear the drawings, and I hope that made a lot of sense. And that is where the minus 1 and 2 came from. All right. So here it just looks like 1 to the left, 2 up. This is using vector form, but we are not using vector form yet. But when you are done with vector questions, you will also understand what we mean by that. All right. So this is basically how we draw it. And if you, sorry, the other question was a good one. It was talking about how to find the center of enlargement, right? So if you have drawn the shape, let's just go back. I want to draw the shape and quickly show you center of enlargement, and then we will stop there. Right. Let's just quickly draw in all the red shapes. So if we give you two shapes like this, and we ask you, please find the center of enlargement. All right. Now, if we ask you find the center of enlargement, so what do? Is the following. You start at this point, any point, and join it with its corresponding point of the other triangle, and you extend the line, right? You extend the line. You do the same thing with the other side. You join that point to the corresponding point and extend the line. Doesn't matter how it is, as long as those 2 points are touching. You do the same thing again with that point and extend the line. When the lines are extended, all 100% of the time, there will be a specific point where the 3 lines meet. A specific point. That point is your center of enlargement. So that is how we find the center of enlargement. And you will write down that coordinate. That coordinate you write down, center of enlargement, is based on the y and the x-axis, the original y and x-axis, not the shapes y and x center, right? It's based on the original y and x-axis. So this x value is -2, and the y value is 1. And you can see it's the same one that we have on top there. So that's how we find the center of enlargement. You extend the lines. In this case, we are coming from a big shape to a small shape, so it's a little bit easier. In other ways, sometimes you can do something else as well. All right. That is it for now. Grade 11, you can log out. I will continue with the class with the grade 9s. Grade 9s, please, you have to log out and log in again, because I have to stop this session. And then we will rejoin. Is there any questions from grade 11 so far? Next topics we will be covering will be on vectors. As you see here, we introduced vectors a little bit, but we will cover vectors in details, and from vectors to matrices. I think that will be the end of this week's lesson. Any questions? No questions? All right. Grade 9, I'm stopping this class and we can restart again. Grade 11s, thank you for joining and enjoy the rest of the day. We will meet each other tomorrow, same time.